In this video, we're going to demonstrate how to do electron configurations. There are three types of notations.
In Hund's rule, electrons must occupy empty orbitals before double occupying them, which means electrons can have a seat in an empty orbital first before a second electron can come sit with them. In Aufbau's rule, electrons fill in the lowest energy orbitals first, much how you would want to use as less energy as possible to pay as least rent. In Lundy's rule, electrons' arrows face the opposite direction in the orbital. In an electron configuration periodic table, there are four groups: the S group, the D group, the P group, and the F group. It is separated using 1s, 2s, 3s, 4s, 5s, 6s, and 7s in the S group in rows, and in the D group, 3d, 4d, 5d, 6d in rows, and goes on. Each box is an electron.
So we have orbital notation, and the box is an orbital where two electrons can fit. You can only have two, and that is what these half arrows are. So this is one electron, and this is two electrons, and they have to be opposite, like facing away from each other, for it to be filled.
So we have some examples. So for orbital notations for argon, which can be seen in the periodic table right here, is shown 1s with 2 arrows, 2s with 2 arrows, 2p with 6 arrows, 3s with 2 arrows, and 3p with 6 arrows. And if we can look here in the periodic table, 1 arrow, 2 arrows. So the arrows represent each atom. So 1s in this row, 2s, 2 arrows, 2p, 6 arrows, 3s, 2 arrows, and then 3p with 1, 2, 3, 4, 5, and 6, which leads us to argon. The next example is the orbital notation for arsenic. And if we can find that in the periodic table, right here, it is shown 1s with 2 arrows, 2s with 2 arrows, 2p with 6 arrows, 3s with 2 arrows, 3p with 6 arrows, 4s with 2 arrows, 4d with 10 arrows, 4p with 3 arrows. And if we follow, 1s with 2, 2s with 2, 2p with 6, 3s with 2, 3p with 6, 4s with 2, 3d with 10, and then if we go to arsenic, which is 4s with 3, which is the same for here.